Hey guys, hope everybody's having a good Easter. We're going to get started on some new material this morning. I've got Eli here with me. If you hear any little noises in the background, that's going to be him. All right. So last week I introduced the Bohr model and had you guys do some practice on the Bohr model. There were a few hang-ups on that. So I just wanted to mention that again. I want to make a point that the Bohr model is not the model that we technically use and is the most accurate today. But we commonly use the Bohr model for illustration and teaching purposes. And really it only does well through about the first 20 or so elements. Because once you start getting electrons into that third energy level, it kind of gets a little tricky, and some of you had questions on that, and rightfully so. So just to show you a couple things there, remember with the Bohr model, you got your nucleus. This first energy level here will only hold 2 electrons. Okay, then it's full. And that second energy level holds 8. All right, now I don't know if I made it clear, but before you go up to a third energy level or the next higher energy level, you have to have that one, the previous one, full. So for example, I couldn't just have 1 electron in this first energy level and then start filling up the second. Okay, you got to completely fill up 1 before you go to the next. So some of you, I noticed you only had 7 electrons in that second energy level, and you started going up to the third and placing electrons there. Well, you can't do that until you get that second energy level completely full with the 8. All right, and I said last week that right now we're working with the understanding that this third energy level holds a maximum of 18, and it does, but those kind of fill out that third level a little differently, and that's when we get into some upper level chemistry stuff and what we'll talk about next year. And at that point, that's when the Bohr model kind of starts getting a little fuzzy. So it was understandable that you guys had some questions, especially related to those electrons that go in that third level. Okay, so today we're going to shift gears and look at a concept called Electron Dot Diagrams. And sometimes they're called electron dot structures. Sometimes they are called Lewis dot diagrams or Lewis dot structures, and it's because of the guy that developed this concept. All right, so before we do that, there's a term that we got to make sure that we are definitely familiar with, and that's this term, valence electrons. Valence electrons are the electrons that are the outermost electrons. So they are the ones that are they're on the outside of an atom. So for example, if we're dealing with an atom of carbon, carbon has 6 electrons. So if we're doing a Bohr model to kind of illustrate it, there's the first 2 electrons in that first energy level, and then the remaining 4 would go in that second energy level. So those outer 4 electrons, that one, that one, that one, and that one, are what we refer to as valence electrons. So they are the ones that are the outermost. Okay. Just another quick example using a Bohr model. Let's go with an atom of sodium. Sodium has 11 electrons. So there's the nucleus. Again, I'm going to use the Bohr model. So the first 2 electrons go in that first energy level. It's full, so now the next 8 will go in that second energy level. So now we've placed a total of 10. So the 11th electron will go in that third energy level. So then there's all 11 electrons. So sodium has 1 valence electron. Now, I want to show you something interesting. I want to go back to the periodic table. There we go. So we just did sodium and carbon. Now, if you remember from a couple lessons ago, maybe 2 weeks ago, when we were talking about the periodic table, I told you to, well, first off, it's arranged in rows, which we call periods, and then groups, the up and down columns, we call those groups. And technically there are 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 18 groups. But I told you that we talk about main groups very often. And this is main group 1 here. This is main group 2. And then we skip the transition metals. And then we come over here and talk about main group 3, 4, 5, 6, 7, and main group 8. And notice here it's stuck hydrogen over here also, because sometimes it acts like those elements that are in group 7. So just disregard that hydrogen on this table. Okay, so now let's look at the atoms that we just drew. Let's check out carbon first. How many valence electrons did we show carbon to have here? There were 4, right? So carbon had 4 electrons in that outermost energy level. The first 2 were inside, and then the remaining 4 were outside. So let's go back up to the table and check out what group carbon exists in. Main group 4. Okay, hang on to that. 4 valence electrons, main group 4. So let's look at the example of sodium that we just did. How many valence electrons did sodium have? 1 valence electron. There was 1 electron in that outermost energy level. Go back to our table. What group, main group, does sodium hang out in? Main group 1. 1 valence electron, main group 1. That is the pattern that you want to lock onto. So essentially, the main group that an element exists in is that number is the number of valence electrons that an atom of that particular element has. So for example, let's look at main group 6 and let's check out an atom of oxygen. And let's draw oxygen over here. Actually, just go to this slide. We'll erase this guy. And we'll start from scratch here. So we're going to draw oxygen. Oxygen has a total of 8 electrons. So let's start drawing it using the Bohr model. There's the nucleus. First 2 electrons are going to go there. There's our first 2. So we've got 6 remaining that are going to go in the second energy level. 1, 2, 3, 4, 5, 6. Okay, so now look at the number of valence electrons we've got. We've got 6 valence electrons. 1, 2, 3, 4, 5, 6. What main group does oxygen exist in? Main group 6. So that's your pattern. So I'm going to come out here and just type that out in words for you. The number of valence electrons an atom has is equal to the main, and this is the main group number the element exists in. So for example, oxygen has 6 valence electrons and exists in main group 6. Okay, so that's the pattern. All right, so now let's tie this into the electron dot structure that I mentioned. So very, very simple now that we know how to determine the number of valence electrons. So what the electron dot structure does is it simply, go back to this slide here, this electron dot structure, it simply uses dots to represent valence electrons. Because here's the truth. Once we get into chemistry, really it's only the valence electrons that we're concerned about. Why? Because they're the ones that are on the outside, and they're the ones that encounter other atoms first, and because of that, they are the electrons that are actually involved in bonding. So we only concern ourselves really with the number of valence electrons. So an electron dot structure uses dots to represent valence electrons. So for example, for the atoms that we just did here on this presentation, we did sodium. All right, how many valence electrons did we say sodium has? Well, if you don't remember, let's go back to the periodic table. Well, I know I have it.
Jelly beans.
Alright guys, sorry you probably couldn't tell on your end, but I had some technical difficulties and I had to bring back up the presentation. So we were looking at sodium, and we go back to our periodic table and we find sodium exists here in the first, in main group 1. There's sodium. So I'll write my numbers back up here. Those are my main group numbers. So sodium is here in main group 1. So that means that sodium has 1 valence electron. Now, for the electron dot diagrams, we use a dot to represent the number of valence electrons. So if sodium has 1 valence electron, I'm going to place 1 dot above sodium. And that's it. That's it. 1 dot for every valence electron. So for example, if I'm going to do oxygen that we just did, we said that oxygen had 6 valence electrons. Now, going back to the periodic table to verify that, there's oxygen in main group 6. So here's how I would draw that with more than 1. We want to think about a clockwise pattern here. So I'm going to put 1 there, and there's different schools of thought here. Some people use like a cross, but I like to go around. And here's the one thing that you got to keep in mind: you want 1 electron dot on each sides, like each 4 sides, before you go back and start to double up. So, for example, 1, 2, 3, 4. So now I've got 1 on each side. I got to place 6. 5 and 6. So there's the electron dot structure for oxygen. Okay, so just a few more. Let's say we've got magnesium, Mg. Magnesium is here. So how many valence electrons? Well, it's in main group 2. So that tells us that magnesium has 2 valence electrons. So how many dots? 2 dots. I'm not going to put both of them over here right now. I want to start at the top and work clockwise. So 1 and 2. That's it. Let's do one more example. Let's say that we've got an atom of chlorine. We go to the periodic table, chlorine, and that might be the most difficult part for some of us, is just finding the element on the periodic table. Chlorine is in main group 7. So how many valence electrons? 7. So there's chlorine. So 7 valence electrons. 1, 2, 3, 4, 5, 6, and 7. There we go. So that would be the electron dot structure. That's 7 for every element in that main group, because they all have 7 except hydrogen. Remember, he's not supposed to be there. Alright, and that's it, guys. So this week we're going to do practice on electron dot diagrams. If you need help or clarification on anything, reach out to me on Teams, and I've figured out that we can do some screen sharing on Teams or Zoom. So if you have a in-depth question, I can just pull up a whiteboard like I just did, and we can actually work through some stuff. So don't hesitate to reach out to me and get help as you need it. All right, hope you guys have a great week. Love you guys. Be safe, and I'll see you next time.